So the question is, how do you do a foot-by-foot profile, and then when would you use it? Well, we didn't have time to go through all the different types of tests that there are, but that was shorthand for basically a TDR-based technology that locates partial discharge activity in a cable system. So what the manufacturers do at the plant is they take a 60 hertz voltage source, they energize it, the sample, and they use a calibrated system to detect what kind of partial discharge they're detecting. That's the key word, detect. So when you say foot by foot, which is basically shorthand for saying being able to identify partial discharge coming from anywhere as a location, you need to have time resolution in the billionths of a second, so 10 nanoseconds would be about 3 feet. So you need to have a very high precision to be able to not only detect the signal, but be able to detect the echoes or time difference if you're measuring from two ends to locate where that signal came from. So identifying all the locations, a termination, a joint, something in the cable, and being able to identify each of those separately and then make judgment based on the standards would qualify as what I would call, again, in the 15-minute talk that we gave, a foot-by-foot profile. So then when would I use it? There's really two, I'd say 3 different categories of, no, there's 4. Okay, 4 different categories of tests. And if you look at the NETA guide, you'll see that it's categorized in really 2 large categories. And that's because I was the chair of IEEE 400 at the time. They said, hey, can you take 400 and kind of plug it into the guide? And I said, it's just going to have a list of the tests. They said, yeah, that's what we want. Okay. So I put a list of tests in there, and it doesn't tell you which one to use. So does the IEC, and so does IEEE. They're all the same. They all say, here are all the different tests you can do. Good luck in figuring out which one to use where. And really that's a symptom of our industry not having enough data to be able to say what tool to use when. So when would you use this type of test? It really comes down to, because it's a sophisticated test and it's not available everywhere, it's really an economic story, so you have to figure out where is it the best place to apply it. In some cases it may not make sense. If it's a cable feeding the parking lot lights, as somebody mentioned earlier, you may maybe just make sure you can energize it. So you just do an insulation resistance test, just say, hey, I can energize it, I'm not energizing into a fault. That's a good idea. Don't energize into a fault. Whereas some asset you might recognize through a process like Chuck was talking about this morning. If I have this fail, it's going to take out this termination, which is a motor lead or bushing on a transformer. It could take out this critical process. It's a pretty easy economic story to identify that's what I'm going to look at with a more costly test. So I think it's, if in a perfect world, you'd always want to repeat the manufacturer's test in the field. But in reality it doesn't make sense. It's not as accessible and it's more costly. So it really is a story of determining where a tool is best used.